Well, hey there, everybody. It's your boy, Mr. Perry, and here we are moving on with Unit 9, Lesson 5. Today, we're going to look at inheritance hierarchies and how creating a hierarchical structure for a program leads to certain benefits. So let's go ahead and hop into it. So, what is an inheritance hierarchy? Well, let's start with the idea. One of the main reasons that we use inheritance is easier maintainability. So, this means that when all of the common attributes and behaviors are put into a superclass and the code is debugged, it's going to work for the superclass as well as all of the subclasses. So, maintainability is this idea that we sometimes need to go back and fix things and, maybe add different attributes or behaviors. And being able to do that in a superclass and then have that automatically inherited by your subclasses is very, very beneficial. And there are different formats of inheritance hierarchies. So let's go ahead and look at some of them here. You can have what's called single inheritance, where you just have one superclass and then one subclass. There is that. There's also what we call multi-level inheritance, where you have one superclass and then several subclasses. But in this case, Bumblebee will extend insect and queen will extend bumblebee. So it's going more in a straight line up and down this way, but you could have more subclasses down below here if you wanted to. But then we're going to look at hierarchical inheritance, and that's really what this lesson is focusing on. I could create a pet superclass, and then from that superclass, I could extend it to include all of the different types of pets that a person might have. And each one of these subclasses will behave in a slightly different way. And even under the dog subclass, I could maybe extend that again and create a service dog subclass. And my fish subclass might also be split into two additional subclasses, tropical fish and freshwater fish. So you can kind of get a sense for why we call this hierarchical inheritance. Uh, Hierarchical inheritance is what allows for what we call polymorphism, which is where all subclasses can be treated as variable types of the same superclass. So again, when it comes to taking advantage of polymorphism, hierarchical inheritance is typically the way to make that happen and the way to really reap those benefits. So let's just remind ourselves of the difference between variable types, which are declared on this side of the equal sign, versus the object types, which is what you see over here. So variable or your reference types over here, variable types of the superclass can hold objects of any of its subclasses. So I can say pet1 equals new pet and just call that one peanut. But then pet2, that can be an object of the cat class because cat is a subclass of it. And then you can do pet3 equals new dog. And then again, dog is a subclass of the pet class. So it also can be an object of the variable type of pet. And then down here, you can have a fish object that is, declared as a variable type of the pet class. And then finally, the rodent subclass can also be an object of the pet variable type. So this is allowable as long as these are either the same class or as long as these are either subclasses of what's over here, then you're in good shape. Now, I also have the option of doing it this way. I could say pet1 equals new pet peanut, and I could say cat pet2 equals new cat catnado, and then dog pet3 equals new dog. So I could also, declare these variables as types of the subclass, and that's just going to alter what methods they have access to and how they behave, or just actually just what methods they have access to. So this is also allowable. What you can't do is you can't have a variable type of a subclass and then set it equal to the object of a superclass. This will not compile. So again, variable types of the subclass cannot hold objects of a superclass. So there you go. All right, now let's talk a little bit about what can be done with superclasses as well as subclasses. So variable types can behave as parameters, right? So I could have a method called compare objects, which expects two pet objects to be passed in, P1 and P2. And variable types of the superclass can also be included in parameters of the method. So this will go ahead and bring in our two pet variable types, P1 and P2, and it will test whether or not they are aliases. So this works. But what's nice about this is, thanks to polymorphism, we can also pass in objects of the dog, cat, bird, fish, and rodent subclasses. So even though this method is expecting two pet objects, or even though this is declared or this is defined with pet variables, if I call compare objects, I can pass in two dog objects to see if they are aliases, or two cat objects to see if they are aliases. So this will work for the subclasses as well, is the point of this whole thing. And then arrays and array list types, we can use the superclass type in an array or in an array list, and then include objects of either the superclass or the subclasses. So down here you see an array of pet objects called kennel1, and it's set to the size of, to the length of 10. And then we're going to go ahead and assign objects of the pet class to be in these kennel spaces. But like pet1 could be an object of the pet class, pet2 could be an object of the pet class. But then if I wanted to, I could make pets 3, 4, and 5 objects of the dog class. And again, because dog is a subclass of the pet type, this is still going to work. So by declaring arrays of the superclass type, you again give yourselves a little bit more versatility in terms of the types of objects you can put in there. The same is true for array lists. So if I create an array list of pet objects, I can now add pet1, pet2, pet3, pet4, and again, it doesn't matter if they are objects of a pet class or any of our subclasses. This will also work. And it's another, example of the advantage of polymorphism. And then this is some alternate syntax that allows you to still add objects of the pet or dog or cat class, but you can actually call the constructor inside the parentheses. So if I've got the array list of pet objects called myPets, and then I do mypets.add, and instead of adding pet1, which means I've already instantiated pet1 up here, it says, pet, mypet equals new pet, and then, whatever info, you can actually shorten things a little bit, and you can just call the constructor in here. And that will also compile, and that will also work. Those will go ahead and create a new pet object and store it in there, create a new dog object and store it in there, a new cat object and a new bird object, and those will all get stored in myPets. Okay, so an inheritance hierarchy of subclasses inheriting from superclasses can be formed with the object class being on top of the hierarchy. A reference variable of a superclass can also be used to refer to an object of the superclass or the subclass. This is called polymorphism, which we're going to see defined more in the next lesson. And it is useful when declaring a formal method of parameters or an array type or an array list type to use the superclass so that objects of all subclasses can also be included. All right, that's it, guys. Thanks so much for watching. As always, be sure to leave a question or a comment, and I will see y'all in class.